everyone, we're going to find a Taylor series generated by the function at the given point, x equals 2. We have f of x equals 1 divided by x plus 1. So we're going to use this Taylor series formula given here. And let's first do some derivatives here. We have f of 2, and that's going to be 1 divided by x plus 1. Evaluating that at x equals 2, that equals 1/3. All right, let's take the first derivative. At 2, it's going to be negative 1 divided by x plus 1 squared. And that's going to be evaluated at x equals 2, which equals 1/9. And then let's do another one. The second derivative of 2 equals 2 divided by x plus 1 cubed, and that's at x equals 2, and that's going to equal 2 divided by 27. And if you wanted to do the next one, if we don't need to do it, I just wanted to show you what the third derivative would be. This would be negative 6 divided by x plus 1 to the fourth. We're not going to write that down, but I wanted to show you these numbers here. Give you an extra number, because we're going to write down the formula now, and we want to write the nth derivative of 2. So for the numerator, what we have is alternating signs, so that's negative 1 to the nth power. And these numbers here are really just n factorial. So the next one I would get would be 24. So that's going to be n factorial. That's why I wanted to show you this one. All right, and then divide it by x plus 1. And then what we're doing is we're going by n plus 1. All right, now let's evaluate that at x equals 2. And that's going to give me equals negative 1 to the nth power times n factorial. The only thing that changes is the denominator, and that's going to be 3. You plug a 2 in there, it's going to be 3 to the power of n plus 1. All right, so let's write this out and expand it. So we're going to get 1 divided by x plus 1 equals 1/3 minus 1/9 times x minus 2 plus 2 divided by 27 times x minus 2 squared divided by 2 factorial plus ... plus, and then we have negative 1, let's put the plus here, negative 1 to the nth power times n factorial times x minus 2 to the nth power, and then we still had 3 to the power of n plus 1 times n factorial. All right, simplifying this, because we have all these numbers here with the factorials, that's going to give us equals 1/3 minus 1/9 times x minus 2 plus these 2's cancels. So you're going to have 1 divided by 27 times x minus 2 squared plus ... plus negative 1 to the nth power times x minus 2 to the nth power divided by 3 to the power of n plus 1. Okay, from there, I can write this as a sum, and that's going to be the sum n equals 0. We're starting at 0. That's why we have that, to infinity of negative 1 to the nth power divided by 3 to the power of n plus 1 times x minus 2 to the nth power. Thank you. Have a nice day. Bye-bye.